AB Calculus 6.3, day number 3. This is the third of 3 videos on volumes. And this volume method, called the perpendicular cross-section, is different than the revolutions in that you won't be finding an axis of revolution, and you won't be creating a region that is circular in nature, potentially. Right? You might be, but likely it'll be a different shape. For example, just to give you a little image of what we're about to do here, let me sketch with some perspective a few of these examples. So here's the x-axis, y-axis. Let's say I have a function f of x, and I want to create a space, right, from, let's say, from x equals 0 out to x equals 3. And this space is going to be created by cross sections, which are triangles. So let's say they're isosceles right triangles with one of the legs right on the xy plane. So for example, it would potentially look like this. Here's an isosceles right triangle, and here's another isosceles right triangle, and so on and so forth. Right, and as you go closer here to the y-axis, you can see that these triangles are becoming smaller. So you kind of get this shape that looks like this. And it's a very odd looking shape, right? And it's kind of hard to tell here, but you kind of have this flat surface on this edge that you can see here, right? And then kind of a curvature as you go down, to the back side of this shape. Okay, so the cross section, if you were to just be standing here hanging out, hands on the hips, looking down the x-axis, you would see triangles. All right, and specifically, you'd see isosceles right triangles. Okay, so this would be our area function, right, in this case, which in this case would be a base of f of x and a height of f of x. So the area function, of course, would be the area of a triangle, which would be 1/2 base times height. So you could write that as half f of x squared. Okay, so that's how we build our area function with these perpendicular cross sections. Now the perpendicular cross section can be any shape that we're told it should be. So for example, in this example 6 here, we only have one example in these notes. I'll maybe create video for a couple of homework problems that look at complex perpendicular cross sections. This one's pretty basic, so let's take a look. Let the base of a solid be the first quadrant plane region bounded by y equals 1 minus x squared to the over 4, the x-axis and the y-axis. So let's sketch that. And it's easiest to visualize this when you give a little perspective to the graph, right? So I kind of tilt the y-axis a little bit. So here's x, here's y. This graph, right, 1 minus x squared over 4 is going to have a y-intercept of 1, right? So if I plug in x equals 0, I get y equals 1. Now if I plug in y equals 0, and I were to solve, I would actually end up getting x equals 2. So it kind of comes down here to this x-intercept of 2, 0. And this graph is quadratic, opening downward. Okay, so if I were to look at it with not this interesting perspective on it, I would see a graph that looks kind of like this. Right? You got 2, 0, you got 0, 1, blah, blah, blah. Okay, so it's kind of hard to see this shape take place here, or this solid start to form, unless I put some perspective on it. So let's take a look at the solid itself. So what I'm going to do is I'm going to create a square. Now, I've drawn this too large for us to really be able to sketch it accurately, so I'm going to shrink it down just a little bit. I'm going to put a 1 here and a 2 here. And I'm going to create squares. So here's a square based on this perspective, right? And I'm going to keep drawing some squares. So you can kind of see this come to life. Now, the number of squares that we would have would be infinite, right? But you can see how this is kind of this interesting accordion-looking shape. All right, so how would I find the volume of this solid? Well, first I've got to find my area function. And because our squares are perpendicular to the x-axis, so since these shapes, right, these cross sections are perpendicular to the x-axis, then our area function will be in terms of x. If they were perpendicular to the y-axis, our area function would be in terms of y, so we'd integrate with respect to y. So just a little niche and heads up there that you might run into along the way. Okay, so again, stand on the x-axis, look down the x-axis. If this were in terms of y, you'd stand right there on the y-axis and do the same, right? So if we look at that, what we'd see is a square, right? Where this right here would be the x-axis. And so you'd see that we have f of x times f of x to find the area of this space. Okay, so f of x is 1 minus x squared over 4. And we're going to multiply it by itself. Okay, so it does say find the volume, so we're going to have to do a little work here. So we're going to integrate, of course, from 0 to 2, right? From 0 all the way over to 2 of this function, 1 minus x squared over 4 squared. Okay, so let's expand the integrand. That would be 1 minus x squared over 2. So if I added negative x squared over 4 to negative x squared over 4, I would get negative x squared over 2. Okay, and then if I square negative x squared over 4, I get a positive x to the 4th over 16. So there's my new integrand, right, in a expanded form. Let's take the shortcut here to make this relatively easy, at least for this example. The intent is not to kind of test you on, at least in this video, on the process of integrating analytically and evaluating. It's more so the setup, and specifically, I want you to be really good at sketching out the region, and in this case, this region was this space right here, right? The bounded region, coming up with your area function, and then setting up the integral. So let's go ahead and use Math 9. We'll plug this integrand in for y1, and let's get a solution. Okay, so my answer here to 3 decimal places ends up being 1.067 units cubed. All right, guys, that is it for 6.3. And I believe, if I'm not mistaken, that's the last video for chapter 6. So I will make a couple more videos and post them about other examples for perpendicular cross-section volumes, just to kind of get a few more different types out there and a few more examples to get you more comfortable. So we'll see you in the next video. Have a great day.